Hello students, very good afternoon. Today's topic is sound, icse board physics. See, sound is the form of energy which propagates through a medium in the form of with the formation of compression and the rarefactions. The particle of sound at the time of compression go closer and closer, and this is called compression. And when particle move away, that is called rarefactions. So the particle vibrate in this manner. It is the mean position 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. This is called one vibration. In a complete one vibration, whatever the distance propagates through a medium is called wavelength. And when the particle vibrate like this, 1, 2, 3, 4, 1, 2, 3, 4, and it perform number of oscillations in a particular time. If in 1 second it perform 2 vibrations, in 1 second it form 3 vibrations, that is the frequency. Means 2 vibration per second, 3 vibration per second, 18 vibration per second, that is called the frequency in hertz. Vibration per second, if you get in medium minute, you have to divide by 60. So you will get vibration per second. Okay. Now here the sound has a particular audible range. We have the audible range, minimum audible range is 20 hertz and maximum audible range is 20 kilohertz. Kilohertz you have to multiply 1000, so it will be 20,000 hertz. Okay, so lower frequency is 20 and maximum range is 20,000. Now here the question, human can hear either up to 20 hertz or greater than 20 hertz or up to the 20,000 hertz. So human ears can detect a sound in the range of 20 hertz to 20,000 hertz if the speed of sound is 330 meter per second. Find the wavelength of audible range. See here. Here audio minimum frequency is 20 hertz and maximum frequency is 20,000 hertz. According to formula, V is equal to F lambda. Sometimes we say nu lambda also. Lambda is the wavelength, F is the frequency, and V is the velocity of sound. So here, if the particle vibrates in a particular time, that is called frequency, okay? And whatever the disturbance traveled a distance in particular vibration, that is called wavelength. If it move fast, the distance will be short. If it moves slow, distance will be large. So, if the velocity is constant, wavelength is inversely proportional to frequency. If the wavelength is large, frequency should be low. If the frequency is low, wavelength will be large. From the relation, velocity is constant 330 meter per second. Maximum frequency is 20,000 hertz, means minimum wavelength. If the frequency is maximum, wavelength is minimum because it is inversely proportional. The wavelength is minimum means 330 meter per 330 is the velocity and 20,000 is that is frequency hertz. You solve this, you will get 16.5 into 10 raised to minus 3. 10 raised to minus 3 means divided by 1000. You can say it is a millimeter. Means if you want to convert meter to millimeter, you have to multiply 1000 and this 1000 will be cancelled out. You will get 16.5 millimeter. Now, when you want to solve the numerical, you should write given. What given? Lowest frequency range is given, highest frequency range is given, and you put the relation also. From the relation V is equal to F lambda. Here if V is a constant, frequency is inversely proportional to wavelength and vice versa. Here, for the minimum wavelength, you have to multiply, you have to put 330 upon 20,000, you will get 16.5 millimeter. For the maximum wavelength, you have to put minimum frequency, V upon minimum frequency is 20 hertz. You put them, you will get the answer. But keep in mind, don't put K, means this is the K means 1000. So in this way, at last you have to write answer. Maximum audible wavelength is 16.5 meter. You should write unit. And minimum wavelength is 16.5 into 10 raised to power minus 3 meter or 16.5 mm. So I think you got the answer. So bye bye students. Next question we'll do soon.